Learners, welcome to today's session in mathematics, and today we will be doing exponents. Now, without any waste of time, let us get into the presentation. That's the presentation outline, grade 8 learners. I will be going through the introduction, covering the basic laws of exponents, mixed exercises on the application of the basic laws of exponents, and then we'll be doing a summary of the basic laws of exponents. Now for the introduction, why do we use exponents, grade 8 learners? Exponents is a way of expressing repeated multiplication of the same. So it's just a convenient way for us to express repeated multiplication of the same factor. So in other words, if we are multiplying 3 by itself 4 times, 3 times 3 times 3 times 3, a convenient way of us expressing that will be in exponential form, meaning what is being multiplied by itself? It's 3. And how many times are we multiplying 3 by itself? We're multiplying 3 by itself 4 times. So that will be written as 3 to the power of 4. And that will give us 81 if that expression is evaluated. Same applies with the repeated multiplication of 7 by itself 5 times. That will be represented as 7 to the power of 5 in exponential form, and that will give us 16,807. Now, basic terminology related to components of an exponential expression. That's what we refer to as an exponential expression, grade 8 learners. Now, what are the components? You have what you call the base, which is the factor that is being multiplied by itself. And you have the exponent, which represents the number of times you are multiplying the factor with itself. And the base with the exponent is being referred to as the power. Now, let us investigate the first law of exponents that says when you are multiplying powers with the same base, you keep the base and you add exponents. Look at the expression on the far left. We have 4 squared multiplied by 3 cubed. Now, if you were to expand out that expression, 4 squared will be expanded as 4 times 4, and 4 cubed will be expanded as 4 times 4 times 4. Now, if you were to count the number of times in which you are multiplying 4 by itself, you will realize that you're multiplying 4 by itself how many times? 5 times. So written as a single power, that will result in 4 to the power of 5. Now again, check the relationship between the exponents in the expression and the exponent in the single power. To get 5, all we did was we kept the base of 4 and we added the exponent of 2 and 3 to get to the exponent of 5. The same example has been illustrated with t to the power of 4 times t to the power of 6. The factors can be expanded in the middle column, and then when you count the number of times in which you are multiplying t by itself, that will be 10 times. So that can also be expressed as a single power to t to the power of 10. So in other words, we can conclude that when multiplying powers with the same base, we keep the base and you add the exponents, which is the first law of exponents that you learn about. Multiplication of the same base, keep the base and add exponents. Now let's investigate the division of powers with the same base. Now what happens when you divide 3 to the power 5 divided by 3 squared? That can be expanded, and after it being expanded, the same factors will divide with each other, and what will be left? Will be left with 3 times 3 times 3, written as a single power or in exponential form. That will be given as 3 to the power of 3. Again, look at the relationship when dividing powers with the same base. Look at the relationship of the exponents in the expression and the exponent in the single power. You will realize that when you subtract 5 from 2, when you subtract 2 from 5, you'll end up with 3. So 5 minus 2 will give you 3. So in other words, when dividing powers that have the same base, what you do is that you keep your base and you subtract the exponent. And the second example illustrates that further. We have p to the power of 8 divided by p to the power of 6. that can be expanded. After expanding, the same factors will divide with each other. You'll be left with p times p, giving us p squared. So therefore, we can conclude that when dividing powers with the same base, what you do is that you keep your base and you subtract the exponents, as indicated there as a general law, as the second general law of exponents. Remember the first one, when multiplying powers with the same base, keep the base, add exponents. Second law, when dividing powers with the same base, you keep the base and you subtract exponents. Now, in the following slide, we now investigate why is it that any base to the power of 0 gives us 1 by definition. And that comes from the quotient rule, or from the second law of exponents. Remember, you learned about division of powers with the same base. When dividing powers with the same base, what you do is that you keep your base and you subtract exponents. So I want you to look at the expression on the far left, as well as the quotient rule on the far right. We have 7 to the power of 5 divided by 7 to the power of 5. By applying the quotient rule, meaning the second law of exponents, when you are dividing powers with the same base, you keep your base and you subtract the exponents. So you'll have 7 to the power of 5 minus 5, giving you 7 to the power of 0. But then what happens if you did not apply the quotient rule? If you decided to expand the expression on the far left, if you expand, you have 7 multiplied by itself 5 times, divided by 7 multiplied by itself 5 times. The identical factors will divide with each other, giving us a solution of 1. So in other words, we can therefore conclude that a base raised to the power of 0 actually gives us 1. So same applies with the second example, where we have r to the power of 8 divided by r to the power of 8. Again, you may expand out your factors as r multiplied by itself 8 times, divided by r multiplied by itself 8 times, giving you 1. Or you can simply apply the quotient rule, which is far more convenient, grade 8 learners. Applying the quotient rule, knowing that you'll have r to the power of 8 minus 8, giving you r to the power of 0, but knowing that r to the power of 0 will always give you 1, because any base raised to the power of 0 is 1, but provided that that base is not equal to 0. So remember that as well. Now, raising a power to another power, we have 3 to the power of 4 raised to the power of 2. That can be expanded. If you count the number of times in which you are multiplying 3 with itself, that will be 8 times. So then written as a single power, it will be 3 to the power of 8. Same applies to the second example. Now we have two different bases. Now we have x squared. We have x our base and y is our base. Now the first factor there, we have x squared multiplied by y, all raised to the power of 3. If that is expanded and you count the number of times in which you are multiplying the same base, if you start with just base x, you'll realize that x is being multiplied with itself 6 times. If you count the number of times you are multiplying y with itself, that will be 3 times, giving us x to the power of 6, y to the power of 3. Now, if you look at the relationship between the exponents in the expression and the exponents in the single power, we'll realize that what happened there is that you multiplied the exponents. So therefore, we can conclude that when raising a power to another power, what you do is that you keep the base and you multiply the exponents. So as summarized there as the third law of exponents that you learn. Now, these are mixed exercises on the application of the laws of exponents. Now, the first question there, the first typical question, what might be and what's commonly asked to grade 8 learners by examiners is that you need to simplify expressions and also to leave your expressions in exponential form. So meaning we need to see the power, the term, the entire term itself. So meaning the base and the exponent. Now what happens if you want to simplify 37 to the power of 4 times 37 to the power of 3 divided by 37 to the power of 5? What you realize that in the numerator you're multiplying bases, you're multiplying powers with the same base. So what you do is that you keep your base and you add your exponents as illustrated by 37 to the power of 4 plus 3. And then you simplify that. That will give you 37 to the power of 7 over 37 to the power of 5. And then you realize that you are dividing powers with the same base. So what you do is that you keep your base and you subtract the exponents. And then you'll be left with 37 to the power of 2. Remember, they said leave your answer in exponential form. Second question here is that we need to simplify the expression and leave your answer in exponential form. So what happens here, you realize that we are raising a power to another power. So we're raising 5 to the power of 9 to the power of 2, also raising 7 to the power of 12 to the power of 2. So in other words, what do? You keep your base and you multiply the exponents. As illustrated there, we have 5 to the power of 9 times 2 times 7 to the power of 12 times 2. Because the third law of exponents tells you that when raising a power to another power, you keep the base and you add the exponents. And then you simplify your exponents, giving you 5 to the power of 18 times 7 to the power of 24. Then you'll realize that we are dividing powers with the same base. So what you do is that you keep your base and you subtract exponents, which is the second law of exponents. And by simplifying that expression, you'll be left with 5 to the power of 8 times 5 to the power of 21. Now realize that 5 and 7 are not the same bases. So in other words, you cannot then add the two exponents because the bases are not the same. You can only apply the first law of exponents provided that you are multiplying powers with the same base. Now, the last example here is that we need to simplify that expression as well. Now we're dealing with a base being raised to the power of 0. So what we do, check the first factor. In the first factor there, we have 3x squared y to the power of 0. If you realize what's being raised to the power of 0 is base y. So in other words, that factor will then give us 1, and that's from the quotient rule, from the second law of exponents. And by definition, we have concluded that any base to the power of 0 will give us 1. If you look at the second factor, we have 3x cubed, all raised to the power of 0. So in other words, that entire expression will then result to 1, as illustrated on the presentation there. So you can see we have 3x squared multiplied by 1 times 1, and that will result in 3x squared as our final solution. So to summarize the basic laws of exponents, those are our laws of exponents, grade 8 learners. Remember, when multiplying powers with the same base, you keep the base, you add exponents. When dividing powers with the same base, keep the base and subtract the exponents. When raising a power to another power, you keep your base and you multiply the exponents. And remember, by definition, any base to the power of 0 will give us 1, provided that that base is not equal to 0. And with that, it brings us on to our quiz that will assess your ability to apply your knowledge to those questions related to exponents. It's just a short quiz. It's about 5 questions. So please complete that quiz and do your best. And with that, grade 8 learners, thank you for your attention and attending today's session. Good luck and keep on practicing. It's only through practice that you can do well in mathematics. Thank you very much.